Okay, so just a couple of things I want to show you before we actually get into solving anything. Radical equations, and equations that contain variables, and the radicand. The radicand is when you have a square root. This number inside here is called your radicand. Whenever you have a variable inside there, then it's called a radical equation. That means we're going to actually be solving for a variable and figuring out what that letter represents. So a key concept. If you square both sides of a true equation, the resulting equation is still true. We've dealt with this concept with adding the same number to both sides, subtracting, multiplying, dividing. We've done all those operations. Now we're just involving squaring both sides. So it says if a equals b, then a squared equals b squared. That's going to be true. If you have 3 equal to 3, if I were to square both of them, 3 squared is 9, 3 squared is 9, it's still true. That's the concept, that's the idea behind what we're going to be working with today. So remembering how we solved for x before, we're going to now get the square root by itself like you got the x by itself. So the first thing we want to do is get the square root by itself. Then we're going to square both sides and then solve for your variable. So as I said here, we're going to be able to square both sides. However, we can't square both sides until we get the square root by itself. This part right here, whatever's inside the square root, has to be the only thing on that side of the equation before you can square both sides. So we have to get rid of the 9. Since it says plus 9, do the opposite, subtract 9. That leaves us with square root of a plus 2 equal to 6. Now that the square root is completely by itself, what I'm going to do, and I'm just going to write this again, is I'm now going to be able to square both sides. Once the square root is by itself, you can square both sides. Now, as we worked with before, if I had square root of 2 squared, that means square root of 2 times square root of 2, and that's a pair, which makes it go out. So this square root and this square symbol, those two actually cancel each other out and leave you with a 2. That same thing is going to happen here. Because I have a square root and a square, they cancel each other out because what I have is a plus 2 times a plus 2, and it's a pair, so it gets to go outside the square root now. 6 squared is 36, and now that's more comfortable. That's something you've worked with before. A plus 2, I'm going to subtract 2 from both sides, and I get a equals 34. If you want to check this, what you would do is take that 34, substitute it back in to your equation to make sure it works. So square root of 34 plus 2 plus 9 equals 15. So we're checking our answers. 34 plus 2 gives you 36. Square root of 36 is 6. And 6 plus 9 is 15. So we have the correct answer. A equals 34. The next one here usually tends to confuse some people. So I want you to recognize that outside the square root, you have a 6 and you have a 2. I'm going to address this problem similar to when we had x's. Instead of writing the square root, what I've just done is put an x in place of the square root. Now, what would you do in this problem? Would you divide by 2 first, or would you subtract 6 first? We know we can't put those together and make it 8, just like you can't put these together and make it 8. This 2 is attached to this square root, just like this 2 is attached to this x. So what you're going to do is subtract 6 from both sides first, and that's what you have to do here. The 2 is attached to the square root, so what you have to do is subtract 6 from both sides. 2 square root, h plus 1 equal to 16. Oops, sorry, that was right. We should have a 10. 16 minus 6 is 10. And then divide both sides by 2. Just like over here, I would then divide both sides by 2. Okay. So we get square root of h plus 1 equal to 5. Now that I have the square root by itself, I'm now able to square both sides. Now I don't put that right here with this. I could, I'm just showing it to you on a separate step, that way you don't get confused on it. Square root of h plus 1 squared, those symbols cancel each other out, you're left with h plus 1. 5 squared is 25. So again, subtract 1 from both sides, and now we get h equals 24. Again, you can check your answer, just plug that back in here. Just to save time, I'm not going to this time, but just substitute it back in, follow order of operations. Squaring each side of an equation sometimes produces a solution that is not a solution of the original equation. These are called extraneous solutions. The reason this happens is because we have h's inside and h's outside the square root, and when we start squaring both sides, sometimes it gives us a solution that doesn't work. This is also going to take us back to the factoring chapter. So we're going to see all sorts of things in this problem. First thing you should notice is you have a square root here. Is the square root by itself on the side of the equation? That's the only thing. So yeah, there's nothing after the square root. There's nothing before the square root. So my first step is I'm able to square both sides. Now, you're squaring this, and you're squaring all of this. Not just the h and the 5, you're squaring the whole thing, which shows you that you're going to have that written 2 times, and we're going to FOIL that. This and this cancel out. We're left with 3h minus 5. This we're going to do off to the side here. We have h minus 5 squared. Well, that means h minus 5 times h minus 5. Binomial times binomial means you're going to FOIL, so h times h is h squared. H times negative 5, negative 5h. Inside, negative 5h. And last, negative 5 times negative 5 is positive 25. Combine your like terms gives you h squared minus 10h plus 25. So when I simplify this, I get this. Now I did that work off to the side so it didn't get too messy over here. So I'm just bringing that over now. Because I have an h squared and an h and a constant, the only way that I'm going to be able to solve this is by factoring. And to factor, what I have to do is get it equal to 0. I'm going to subtract 3h to both sides, put that right with my other h. Add 5 to both sides. Now I have it equal to 0. Since I have it equal to 0, I see an h squared, h constant. I have 3 terms of trinomial. So with a trinomial and no number in front, what I'm looking for are numbers that multiply to give me 30, that add up to negative 13. Those two numbers would be negative 3 and negative 10. So with no number in front, I can go straight to my 2 groups of parentheses, h minus 3 and h minus 10. Since it's equal to 0, I now have to set each of them equal to 0 and solve for my variable. So adding 3 to both sides, h equals 3, add 10 to both sides, h equals 10. Now, like we said, there's extraneous solutions. I need some more room here, so I got to get rid of this. We have extraneous solutions. So with extraneous solutions, you have to check your answers. So 3, I'm going to plug it back in there and show you sometimes they work and sometimes they don't. And the reason is with this step right here. By squaring it, sometimes gives you something where you just got to double check to make sure it works. And you'll see right here, this gives you negative 2. Here we get 9 minus 5, or what you can look at, can a square root ever equal a negative number? This gives you 2 equals negative 2. That does not work, so we got to cross off that answer. We're going to do the same thing to check the 10. So square root of 3 times 10 minus 5 equals 10 minus 5. This is going to give me a positive. That's a good sign. Over here we have 30 minus 5. 30 minus 5 is square root of 25, and square root of 25 is 5, equal to 5. That one works, so h equals 10 is the only answer that works.